Hello everyone, this is Gedish here. In this video, I'm going to go through the AQA Combined Science Chemistry Paper 1, higher tier from 2021. Question number 7 is on the topic of energy changes. Methane, ethane, propane, and butane all react with oxygen to produce carbon dioxide and water. Suggest why a mixture of methane and oxygen does not react at room temperature. Answer in terms of particles. Now, for it to react, the particles need to collide and above the activation energy. Now at room temperature, the particles don't have enough energy to react. So the particles collide, but at room temperature, RTP, the particles have insufficient energy to react. So they haven't met the activation energy. So this collision is not successful. Table 3 shows the energy released when methane, ethane, and propane react with oxygen to produce carbon dioxide and water. Predict the energy released when butane reacts with oxygen to produce carbon dioxide and water. Now, it would be, we can work out how much it's actually going up by each time. So if I 1160 minus 680 is 480, and if I do 1640 minus 1160, I get 480 again. So all I have to do is add 1640 plus 480 will give me 2120. It's going up by 480 kilojoules per mole. Propane reacts with oxygen to produce carbon dioxide and water. The displayed formula for the reaction is shown. Okay, this reaction is exothermic. In this reaction, the energy released when forming new bonds is 1640 kilojoules greater than the energy needed when breaking bonds. So they've given you the overall energy change, which means, okay, they are asking us to calculate the carbon-carbon bond energy. So on this side, bonds are broken. And on this side, you've got bonds made. So you have 1, 2, all right, carbon-carbon bonds. Thus, you're breaking 2 of them. 6, 7, 8. So carbon, hydrogen, that's 8 of them. And oxygen, double bond oxygen, that's 1 of them. You're breaking all these bonds. You're making, actually, this is 5 oxygen molecules, so that would be 5 of them. On this side, you're making carbon oxygen double bond. There's 2 in one molecule, so that means there's 6. And oxygen hydrogen molecules in one water molecule, there's 2 because there's 4. That's 8. So let's rewrite these values. So let's write this down first. Bonds broken, that's is equal to 8 of the carbon hydrogen bonds, so that's 8 times 410, plus there was 2 of the carbon bonds, so you can write it as 2x, plus 5 oxygen bonds, so 5 times 500. That gives me 5780 plus 2x. Bonds made would be 6 carbon oxygen bonds, so 6 times 740 plus 8 of the oxygen hydrogen bonds, 8 times 460. That gives me 8120. So the energy released is equal to bonds broken minus the bonds made. So the bonds broken was, remember, 1640. Now this needs to be a negative value because the energy was released, is equal to 5780 plus 2x minus 8120. So that would give me 2x is equal to 700. So x is equal to 700 divided by 2. That's 350. So that's 350 kilojoules per mole. That brings us to the end of this paper. Thanks for watching the video. Hopefully you find it useful. If you did, subscribe to the channel for videos on chemistry and biology and physics papers. Thanks again. Bye for now. This is Kadish.